Hello everyone, welcome to my channel. This is the third and final video on gradients editing on the fly. So finally, we have come to the key parts of this series, which is to how to edit gradients. And this also means that we're gonna look at how to tweak the optimization along the training of the deep learning neural net. And this can also show you how to change the optimization procedures, such as you can invent new ways to do the optimization and see if it works compared with the current popular ways in terms of how to do this. So as you can see that I have again some printers here. So it's always good to print out or trace the change of certain particular parameters. In this case, I'm tracing the values of the upper layer. And the first way to edit the gradients, which I want to show you, is called gradient clipping. And now you may have heard it before, right? It's because it's quite widely used in current mainstream training of neural networks. For example, in training games, and you usually clip the gradients either by its value or by its norm. And the reason is because we do not want the gradient to be exploding. So if the gradient is getting bigger and bigger, then it's sort of exploding. And so we do not want to the gradient to diminish. So this is another problem. So now the way we can control the iteration of the gradients is themselves through editing or clipping these values directly. So in this case, I'm calling the function clip grad value, which is directly available in PyTorch, the Torch you would use. And the parameter passing here is to say, of all the gradients I have calculated in current iteration, I do not want any of them to exceed the value of 0.05. Right. So let's see how it works. So here I've run the operation, and as you can see, that this is the gradient value before clipping for the values, and this is after clipping. So for those that exceeds the 0.05, which is in this case the 0.07, we have successfully clipped it to 0.05. So that's one way to clip it. And then after this iteration, after this operation, we continue the following operating procedure. And this can be applied also across all the parameters or all the gradients of the parameters. So that's one way to do this. Another way which I think could be helpful, right, just for the sake of experimentation, is to do gradient masking. And the masking idea is also quite used in architectures such as masks RNN, right? So this is something that's actually quite used in the also used in the deep learning literature. So the way we can do this is, the main idea is that we're gonna have a mask for each and every gradient, right? So the way we compute the gradient is through generating a random number and to say between 0 and 1. And if it's below 0.5, it's gonna be 1, otherwise it's gonna be 0. So for those that's equal to 1, we're gonna remain as it is. If it's 0, then it's gonna be switched to 0, meaning it's gonna be disabled. So first we create these binaries, a list of binaries, right? So this is generating a list of numbers and to see if it's compared against the 0.5. So this itself contains a list of zeros and ones, the binaries, and then we're gonna focus on or extract the values of the upper layer, and then multiply it with the gradients, and multiply the gradients with the grad mask. So the .mal underscore function itself is going to change the gradients in place. In place meaning after doing this operation, is going to change the value directly. Right. So this is another way we can do the gradient masking, meaning after the gradients change, after the gradient operation, only some portion of the gradients will be changed. So let's see if it works. Now, as you can see, that this is before gradient masking, this after gradient masking. So I have successfully masked some of the gradients. For example, this guy used to be 0.006, now it's 0, right? But some in other times this remains as it is. So this is another way to do gradient masking. Now, third way would be the gradient perturbation. So as we know that the noise itself could be sometimes very helpful. It can be a good thing. No matter we add noise to the parameters, to the inputs, outputs, right? So it usually turns out to be helpful. And also even in stochastic gradient descent, the sort of the profile of the training path itself is very noisy compared with the full gradient descent. And the sort of the noises in the training path is also something that can contribute to its the generalization performance. So in this case, noise in implementation is also a good thing. So now in this case, we're focusing on adding noise to gradients. And the way we can do is to say we're going to focus on the biases as well in the upper layer and generate a list of random noises, right, which follows a normal distribution with a mean 0 and 0.1 standard deviation. And what we only need to do is to specify the shape of the random noise as the same as the gradients. So we can extract the shape by the grad dot shape. And this is to say we're going to add a little bit of noise to all the gradients, right? So this is the addition operation, and then see if it changes gradients. So again, this is an in-place operation, meaning it's going to change the gradients in place and also on the fly if we embed it in the training procedure. So after run this, again, it's very fast. And we have successfully added a bit of noise for each and every gradient for biases, right? You can see every guy is changing. Okay, so lastly, we can do gradients replacement. So this is again just some potential way we can go about editing the gradients. So the way we can go about doing the replacement of the gradients is that we also have again have the noise, and with the noise here, we can just directly assign the noise to the gradients. So this is another way to do this. And if we see the outputs, you can see that all the gradients are being changed. Right, so all the gradients are being changed. So this is a gradient replacement. And now the possibilities, there are lots of possibilities we can go about how to deal with the gradients. So we can replace it, we can put up using the noise, and also we can mask it. And also even we can combine any of these different approaches to form a customized way to deal with the gradients. And I think this could be an interesting research direction because it's not really quite well studied, but it's also I think it's a good way to say how these noises added in the gradient themselves could be helpful in changing or even possibly improving the performance or the predictive performance or the generalization performance of deep neural networks. And yeah, thanks for watching the video. And this is again end of this tutorial. And I hope you have benefits from the sharing. And if you have any comments, let me know and try to answer. Thank you.